Welcome all to the session of calendars. In this session, we are going to discuss the questions and concepts of calendars. Calendar is a quite frequent topic in the competitive exams as well as in the placement exams. So first of all, we'll discuss about the content of this particular session. We have introduction to the calendar, ordinary year, leap year, odd day concept. Then we have major type of questions, finding day for a date, conventional method or shortcut we will use, finding a year having the same calendar versus another like as another year, and practicing the questions after that. So first of all, origin of calendar, it was started in history. I'm not going to discuss that much in for that one. We are starting with the main concept here. So in calendars, we have content as introduction, and then we have ordinary year and leap year, concept of odd days, then finding a day on a given particular date, and also we will practice some questions that how to find the calendar for the same calendar for the different years. So first of all, what are the ordinary and leap year? If I talk about ordinary and leap year, the time taken by Earth to complete a revolution is said to be complete a year, and we have this as 365.2425 days. So these 2.24 days are considered into the ordinary year, but if we calculate into the 4 years, it becomes one full day. Hence, that every 4 years we can say there is a extra day which is called a leap year. So in that day, in that particular year, we are taking 366 days. Now, so 365.24 when ignored, like if I am ignoring the 0.0025, I'm getting 0.24, and this is taken as 0.25 exactly, approximately. So we are getting this only the 365 days taken, 365 days are here, and extra in 4 years become 360 days. This is the answer for like the question why we have the leap year and non-leap year. After that, how to check a leap year for a non-century year? If a non-century year is there and this is not ending with double zero divisible by 4, we can say then it is said to be a leap year. Last period of a year should be divisible by 4, then it is said to be a leap year. Reason, as explained in the previous slide, that the 0.25 we are getting extra for every year, that is from here we are getting one extra day, and that is making a leap year here. So for example, if I say 1844, 92, 2012, 2008, 2016, these are some the leap years examples. Now what about these century years? We were talking about the ordinary years, now century years. In the century year ending with 00 will be taken as leap years only, but it should be divisible by 400. Why? The reason is the approximation that we have taken here, 365.24, it does not include the 0.001 value. As in the previous slide we discussed that we have taken 0.24 and approximately we were taking 0.25 in that case. So every 100th year it is divisible by 4th, divisible by 4, and it ends up in the ordinary year. So that is why 400 year is a leap year. In this case we will see, so roughly we can say that 100, 200 and 300 are not leap year, although they are divided by 4, just because the 0.01 addition to the every 100th year. Now the answer also lies, let us check that 365.24, we initially ignore this one, which is a negligible value for 1 year, but in 400 years this becomes a complete day. So we added this extra year to the 400th year. That is why we can say every 400th year, like divisible by 400, is a leap year. So examples are 400, 1200, 600, 2000 are the examples of leap years, right? So odd day concept. Next, if I say in a given period the number of days more than the complete weeks are called odd days. For example, 15 total days, we have one odd day. 15 divided by 7, we have one odd day. So if I take the January as a month, January 37 days divided by 7, so we have 3 odd days, right? So the odd value lies from 0 to 6. If the odd days value is more than 6, keep dividing 7 until we are getting the uh, remainder value less than 7. So from here we can find the answers easily while solving the question of calendar. So in a single year, we have 365 days, and 365 divided by 7, we have one odd day. And in a leap year, we have 366 divided by 7, we have two odd days. This is simple, that dividing 365 and 366 by 7 to get the number of odd days here. So finding the odd days throughout a century or year span, let us see through example how to find the number of odd days throughout a year or a century. So in 35 years, we have to find the number of odd days. So what we have to find first, that how many leap years are there. So first of all, we will divide 35 by 4 to check how many leap years are there. So we can see that there are 8 leap years, because less than 35, the multiple of 4 is 8. 8 into 32. 8 into 4 is 32. We are getting 27 ordinary years and 8 leap years. So in each and every leap year, we have 2 odd days. So 16 odd days from leap years, 27 odd days from the normal year. So total number of odd days will be 1 here in 35 years by adding all the values, dividing it by 7. Now, following the same steps, we can find the number of odd days in 100. So 100 will give 24 leap years, 76 non-leap years. 24 will become 48 because we have 2 odd days here. 76 remains 76. By adding these two, dividing it by 7, we are getting remainder 5. That means there are 5 odd days in 100 years, right? So the first year we have 24 years, not the 25, because 100th year cannot be a leap year. So odd days in a century, if I calculate, we have 3 here. In 100 we can say 5. Then 200 we have 10 by 7, 3. Then 5 by 3, 5 into 3, 15, 1 odd day here. 400 years. Remainder is 0, because we know that 1 extra day is added, as we did in the last slide. So similarly, we can get the answer from this, like first century 105, 3, 1, 0. So 300 years will have 1 odd day, 200 years will have 3 odd days. According to this, we will apply this in the questions. So odd days in the months are these: January having 31 days, that is why 3. February in the case of non-leap year 0, leap year 1. So that is how we are getting the number of odd days in number of given particular months. So now we will solve one question here to understand the concept that we have learned of the odd days. So if May 10, 1997 was Monday, what will be the day on October 10th, 2001? So how to solve this question? First of all, we say that May 10, 1997, we have to find the number of odd days from May 10 up to October 10, 2001. So from May 11 to May 10, we have one odd day, because we know this is an ordinary year and we're getting one odd day. So from May 1998 to May 1999, we have one odd day. Then again, we are finding total odd days here. So we are getting 5 odd days here from May 11 to October 10, 2001. So now remaining 21 days of May will giving 0 odd days, because 21 is the multiple of 7. So that is how, since May 10, 1990 was a Monday, then 4 days after Monday will be Friday. So October 10th, 2001 will be a Friday in this case. So from here we can see total number of odd days were 4 here, right? Total number of we were getting 18, then we are getting 4 here. So total number of odd days are 4. From here we are getting the answer of a give like this was the answer. They're asking day was given. From there date was given. We have to compare the date with the other date to find the day on that particular asked date. So finding a day or for a particular date, we can say we can apply the same concept. So for example, if I use the conventional method here, Independence Day of India, Republic Day of India. So we know Independence Day of India is, we can take as 15 August 1940, 15 August 1947. So we'll solve the question here. For that, I'm writing the values. August 1947. So now we will use the learned concept here to answer this question. First of all, I can write 1900 years into 1600 plus 300 plus 46 years completed plus 7 months completed plus 15 days. So in 1600 years, we know this is divisible by 400. There will be 0 odd days. Then 300 years, we know there is 1 odd day. 46, we can say there would be 11 leap years, so 22 odd days plus 35 ordinary years plus 7 months. As we know, the first 6 months we have 6 odd days, so 7th month for July will have 3, we are writing 9, so 15. So add up all the values. If I adding here, it is 0 plus 1 plus 22 plus 35 plus 9 plus 15 by 7. So we are getting 5 as the remainder after solving this. So that means the Independence Day of India was Friday. 5 means Friday. Already we have used the table to solve this. Like here we have 5 as Friday. So that is the answer for this question. Last type of question that we have to find here, it is for a year to have the same calendar with 2007. The total number of 8 days from 2007 should be 0. So if a year having 0 odd days as compared to the next one, we have then the same calendar. So there is a method to solve that one. So from 2001, we have 1 odd day, 2008, 2 odd days, 2009, 1 odd day, 2010, 1 odd day, 2011, 1 odd day. So counting like this till we are getting the 2007 to 2018. We are getting the 0 odd days. Like the total number of days are the multiple of 7. That is how we are getting 2018 as the answer for the same calendar of 2007. For 2007 is given. From there we are calculating year to year that how many odd days are existing. So 2007 is a normal year. 2007 to 2008 we have 1 odd day. 2008 to 2009 we have 2 odd days because 2008 is a leap year. So that is how at end till counting 2018 we are getting 0 odd days. That means multiple of 7 we are getting as the odd days. So we are getting the answer as 2018 for this. So shortcut to when you're not crossing an ordinary century, we can use that leap year calendar repeats after 28 years. The condition is if it is not crossing a ordinary century. So 20 years, 28 years for a leap year. Then 6 years after that we having the first. Second year we are having the 11 years. Third calendar will be repeated after again 11 years. Again the leap year 28. So if a given year is at first position, then the next repeated calendar year is given plus 6 years. So according to this, if I say find the first year as calendar as that of 2007 will be repeated. So as we did in the with the method, now we will solve it with the concept here that we know 2007 is here. So by the given rule, we can say 2007 is at the third position from the we can say from the a leap year. So it would be here. From a leap year, we have third position of 2007, or you can take 2008 and you can calculate, or you can take 2004 as the reference to calculate. 2007 is third position from 2004, which is for the leap year, and that is why we are taking 11 years, adding to the year and getting the answer as 2011. So this is all about the concept of calendars, and the questions are solved based on the concept being taught. We have to remember how to solve the odd years, whether like if I'm talking about the finding a particular date or finding the same calendar. The only thing we have to understand here is the number of odd days. Once we have gone through the concept of odd days, like I have solved here, so this concept will tell you the each and every will give you the each and every answer for the given questions. And there are two type of the main questions. First is finding a day on given date, or finding the same calendar as for the given years. So for this session, it is till with calendar this is done. So that is all for this. Thank you.